Earth's moon is the only place outside Earth where humans have set foot. The brightest and largest object in our night sky, the moon, makes Earth a more habitable planet by moderating our planet's wobble on its axis, leading to a relatively stable climate. It also causes tides, creating a rhythm that has guided humans for thousands of years. However, when the Apollo astronauts returned from the moon, it was not without strange and dangerous surprises. The dust that clung to their spacesuits caused sore throats and watery eyes. The particles were sharp and abrasive, and astronauts called it lunar hay fever. The moon holds secrets that could have catastrophic consequences for the future of humanity, as NASA experts warn of catastrophic flooding it could unleash on Earth. What is happening on the moon that could trigger such massive floods? Despite its serene appearance, the moon is a very active celestial body that has a number of interesting characteristics. Although it is only a third the size of Earth and has a radius of 1,740 kilometers, it is an astonishing 384,400 kilometers from us. To get an idea of this distance, you could fit 30 Earth-sized planets between us and the moon. Unlike the Earth, which takes about 365 days to go around the Sun, the moon completes its orbit around the Earth in just 27 Earth days, and at the same time, it rotates on its own axis. However, due to the movement and rotation of the Earth, it appears to us that the moon orbits the Earth in a period of 29 days. Beneath its peaceful surface, the moon has a great deal of activity, making it a fascinating celestial object. But don't be fooled by its calm appearance. The moon was once home to active volcanoes that have since become dormant. Thanks to probes and landings, we have discovered that its surface is bombarded by asteroids, meteorites, and comets due to its thin atmosphere. The constant impacts have caused countless craters, including the enormous Tycho crater, which spans more than 85 kilometers. As a result, the moon's surface is now fragmented into a pile of charcoal gray dust debris and rocky remains known as lunar regolith. This may not seem like a big deal, but it is actually a nightmare for any astronaut hoping to explore the moon. Because regolith is electrically charged and sticks to everything, creating chaos wherever it lands. Have you ever wondered how a small silver ball can have a big impact on our lives? If the moon disappeared, at first, perhaps we wouldn't notice the difference. But over time, we would begin to notice changes in our world. Night skies would be darker, which would be great for astronomers, but creatures that depend on the moon's light to reproduce, such as corals and fish, could suffer the consequences. The lack of eclipses would be disappointing for sky lovers, but that's just a minor change compared to the larger impact of an absent moon. An immediate effect would be on the tides, which are caused by the gravitational forces of the moon and the sun. This creates 2 low tides and 2 high tides as the Earth spins, but the moon's orbit and the sun's influence make the system be complicated. The sun has about half the influence of the moon on Earth's tides. Alignment produces spring tides and a right angle produces neap tides. Without the moon, the tides would be simpler but weaker. Although eliminating the moon would have some immediate good and bad consequences, it would not be the end of the world. The real problem is that the Earth's rotation would become unstable over time due to a slight wobble in its axis tilted at 23.4 degrees relative to our orbit around the Sun. The removal of the moon would have both immediate and long-term consequences. Without the moon, the tides would be simpler but much weaker, and the Earth's rotation would become unstable, causing extreme climate change. The gentle wobble that currently stabilizes the Earth's axis would become erratic and extreme, resulting in seasons disappearing, huge daylight and temperature differences throughout the year, and different parts of the world experiencing ice ages every few years. Thousands of years. The moon is important to us because it causes tides and helps stabilize the Earth's rotation. However, the moon also has a new effect on us called the lunar wobble. The moon's inclined orbit causes its position to change over time, affecting the height of the tides. This could worsen the effects of climate change on coastal communities. But we don't have to worry about losing the moon anytime soon. Scientists at NASA and the University of Hawaii have discovered this new effect and are studying its implications. While scientists have long known about the moon wobble, the potential consequences are only beginning to become apparent. NASA is particularly concerned about how this phenomenon could worsen existing climate concerns. You must have realized by now that the moon is not just wobbly, still has a profound impact on the Earth's tides. The scientific community had already anticipated that tidal flooding would get worse, even without taking the moon wobble into account. But to make accurate predictions about these tides, scientists must examine a large amount of complex data that includes factors such as weather patterns, astronomical events, and regional tidal variations. The moon wobble is now an additional factor that you must incorporate into your models. NASA experts have warned that the moon wobble will raise sea levels, resulting in significantly increased flooding along all U.S. coasts in the coming years. The moon is currently in a tidal amplification phase, and coastal areas of the United States will experience intensified flooding during high tides due to the lunar cycle. However, northern coasts, such as those of Alaska, may have a brief respite due to long-term geological processes. NASA predicts that flooding could triple or quadruple compared to recent disasters. To put things into perspective, we're talking about 600 floods in 2019 alone, and the situation is only getting worse. The most worrying thing is that the low-lying areas are the most vulnerable, which means they will be the most affected. But what exactly would these floods look like? Researchers have been working tirelessly to predict its appearance, and the results are discouraging. Imagine this: floods coming in clusters that could last weeks, with cities being hit on consecutive days or every other day. To come up with these projections, experts have been monitoring 89 tide gauging stations in every coastal state and territory except Alaska. They've even created a unique statistical approach to mapping the most common sea level scenarios and flood thresholds, and it doesn't look good. Phil Thompson, who is an assistant professor at the University of Hawaii and the lead author of the study, has highlighted that high tide flooding is often perceived as less significant than storm surge. However, flooding that occurs regularly, 10 to 15 times a month, can cause substantial economic damage critical infrastructure, and lead to food instability. Farmers can also lose their crops and livestock, and leaking septic tanks can become a public health problem. In the United States alone, damages could run into trillions of dollars. Floods caused by this lunar oscillation are not typical and have been called mutant floods, posing a long-term challenge for the United States and other coastal areas around the world. NASA Administrator Bill Nelson has highlighted that the combination of sea level rise, the moon's gravitational pull, and climate change will continue to exacerbate coastal flooding. NASA's Sea Level Change team is providing crucial information to help at-risk cities take preventive measures to protect the environment and people's livelihoods. Planning needs to start now, as floods can persist for a decade once they start, and NASA's release of these findings could make a big difference in preventing future flood disasters. However, it seems that China is not satisfied with the amount of energy it gets from the sun, so it is creating one in its own backyard, and it is more than 5 times hotter than the real sun. However, all this sun replication comes with a whopping $1 trillion bill. Before we talk about how China's artificial sun works, why is the country building one? The goal is to provide almost unlimited clean energy, mimicking the natural reactions that occur within stars. The artificial sun uses the same method as the original sun to produce energy, the holy grail of clean energy production, Since the process does not require fossil fuels and leaves no hazardous waste, unlike the nuclear fission process that drives commercial nuclear energy production. Researchers also say there is much less risk of an environmental disaster. So how does China's artificial sun work? It works just like the sun. The solar energy that reaches Earth is created by nuclear fusion that occurs in the sun. Nuclear fusion occurs when protons from hydrogen atoms collide violently in the sun's core and fuse to create a helium atom. This process, known as the proton fusion reaction, emits an enormous amount of energy deep in its core. The sun fuses about 620 million metric tons of hydrogen every second. The reaction is possible thanks to the extreme pressure and temperature within the core of the sun, which is estimated to be equivalent to 250 billion atmospheres or 25.33 trillion kilopascals and 15.7 million Kelvin, respectively. The net result is the fusion of 4 protons or hydrogen nuclei into an alpha particle, 2 protons and 2 neutrons bound together in a particle identical to the helium nucleus. 2 positrons and 2 neutrinos are released from this process, converting 2 of the protons into neutrons and energy. China's artificial sun was able to superheat a loop of plasma to 5 times the temperature of the sun for more than 15 minutes. The reactor, known as EAST or Experimental Advanced Superconducting Tokamak, maintained a temperature of 158 million degrees Fahrenheit or 70 million degrees Celsius for 1,056 seconds. The scientific community praised this achievement because it is a significant step toward creating a nearly unlimited source of clean energy. EAST surpassed the record set by France's tokamak formerly Tour Supra in 2003, in which plasma in a winding loop maintained similar temperatures for 390 seconds. Meanwhile, EAST set another record a year ago when it ran for 101 seconds at 216 million degrees Fahrenheit or 120 million degrees Celsius. Replicating the sun is not an easy task because you try to recreate the conditions inside the sun and other powerful stars. EAST uses the tokamak design, a machine that uses magnetic fields to confine a plasma in a donut shape that scientists call a torus. Fusion energy scientists say tokamak is the leading plasma confinement concept for future fusion power plants. In a tokamak, magnetic field coils can confine plasma particles to allow the plasma to achieve the conditions necessary for fusion. The heart of the tokamak is a donut-shaped vacuum chamber. Inside the chamber, a gaseous hydrogen fuel is placed under extreme heat and pressure, turning into plasma, a hot, electrically charged gas. Scientists can control the charged particles in the plasma using massive magnetic coils placed around the chamber. Control is necessary to keep the plasma away from the chamber walls. This is because contact between the electrically charged plasma and the walls of the reactor could cause instantaneous meltdown. A powerful electric current is passed through the container, and the hydrogen gas fuel is ionized, that is, the electrons are stripped from the nuclei and form a plasma. As the plasma particles become energized and collide, they also heat up. Other heating methods help bring the plasma to fusion temperatures between 150 and 300 million degrees Celsius. The particles become energized enough to overcome their natural electromagnetic repulsion upon collision and fuse, releasing colossal energy. With all of these extreme temperatures, one may wonder if tokamaks are safe, but the reality is that the chamber of a modern tokamak typically contains less than 1/10 of a gram of hydrogen fuel at any given time. If an interruption occurs during a pulse, the reaction cools and ends immediately, meaning that a nuclear explosion is not possible in a tokamak. Additionally, the fusion process is inherently safe, but scientists are building a number of additional safety measures into fusion power plant designs, so even a catastrophic rupture in a tokamak would only create very low levels of radioactivity. Outside the plant premises. One of the main obstacles Chinese scientists had was how to handle a plasma hot enough to fuse. The fact is that fusion reactors need very high temperatures, which are often higher than those of the sun, because they practically have to work at pressures much lower than where fusion occurs inside the sun. It's one thing to cook plasma at temperatures higher than the sun, but it's another thing to enclose it so it doesn't burn off the reactive walls with lasers or magnetic fields, which would ruin the fusion process. China has spent a whopping $700 billion on yeast, and is on track to spend about half that amount by the time the experiment concludes in June. Meanwhile, yeast is a precursor to an even larger fusion project known as ETA, the International Experimental Reactor being built in Marseille, France. The program involves 35 countries, including EU countries, the UK, China, India, and the US. Thanks to lessons learned during the development of yeast, ETA contains the most powerful magnet in the world, making it capable of producing a magnetic field 280,000 times stronger than that of the Earth. A powerful electrical current is being run through the container and the hydrogen fuel gas is ionized, that is, the electrons are separated from the nuclei and form a plasma. As the plasma particles become energized and collide, they also heat up. Additional heating methods help bring the plasma to fusion temperatures between 150 and 300 million degrees Celsius. The particles become energized enough to overcome their natural electromagnetic repulsion upon collision and fuse, releasing colossal energy. Despite these extreme temperatures, it is important to note that the chamber in a modern tokamak typically contains less than 1/10 of a gram of hydrogen fuel at any given time, and if an interruption occurs during a pulse, the reaction is immediately cooled and finished. This means that a nuclear explosion in a tokamak is not possible and that the fusion process is inherently safe. Additionally, scientists are building a number of additional safety measures into fusion power plant design so that even a catastrophic breach in a tokamak will only create very low levels of radioactivity outside the structure. One of the main obstacles Chinese scientists faced was how to handle a plasma hot enough to fuse. Fusion reactors need very high temperatures that are often higher than those of the sun because they practically have to operate at much lower pressures than where fusion takes place inside the sun. The production and control of such a self-heated plasma has been the goal of magnetic fusion research for more than 50 years. The fusion reactor will come online in 2025 and will give scientists even more information about the feasibility of harnessing stellar energy on Earth. In theory, deuterium, which contains heavy hydrogen atoms, can be obtained from Earth's oceans. It is estimated that 1 liter of seawater has enough fusion material to produce energy equivalent to 300 liters of gasoline, meaning we can obtain an unlimited supply of energy. ETA designers claim that inserting 50 megawatts of power into the system to start the reactor will produce 500 megawatts. The internal volume of the tokamak ETA is a record, with a plasma volume of 830 cubic meters, which will allow for the first time to produce a combustion plasma in which the majority of the heating necessary to maintain the fusion reaction is produced by alpha particles, generated during the fusion process itself. Deuterium, which contains heavy hydrogen atoms, can theoretically be obtained from Earth's oceans. It is estimated that 1 liter of seawater has enough fusion material to produce energy equivalent to 300 liters of gasoline, so we can obtain an unlimited supply of energy from China's artificial sun. China is not stopping there as it is pursuing other programs developing nuclear fusion energy and will finish developing another tokamak in the early 2030s. What do you think of China's artificial sun in the comments section below?